Yes, it's Salah Nasri here, and yes, I have a special announcement. The Game of Chip has just hit 20,000 orders on Amazon. Thank you to everyone who placed the order. The book was just released in December, so I'm very, very grateful and surprised to date. If you are someone who is intrigued, curious about how the semiconductor ecosystem works from beginning to where we are right now, this book was written with you in mind. So order it, read it, and it is pretty much a handbook of the whole ecosystem. In the meantime, enjoy the next episode and don't forget to hit that subscribe button. Biggest myth about what test and measurement actually contributes to semiconductor yield?
That it's non-value add. Otherwise, you can imagine as a 16 high stack, if one of the 16 die is bad, all 16 are bad.
Right.
There's very little opportunity for rework, redundancy, things like that. It's just a theme. My 25 years in the industry, I've never seen this pace of technical innovation and adoption.
Our guest today is Dr. Mike Slessor, President and CEO of FormFactor since 2014.
PhD in Aeronautics and Physics from Caltech. Before FormFactor, he led MicroProbe, the company FormFactor acquired in 2012. He now runs a 2,200-person business at the test layer of the semiconductor industry, the layer where bad die get caught before they cost a fortune downstream.
He sat down with Salah 24 hours after FormFactor's Q1 earnings call.
Which technical decision in the last 5 years that you made personally over your engineering team's recommendation, and how did it turn out?
And this is part of my evolution as a leader.
Yeah.
I don't think I've made one.
But what is the question your investors keep asking that you think misses the point?
But when it's time to push the chips in the middle, push the chips in the middle.
If FormFactor is a $1.5 billion revenue in 5 years, are you a 3,000 person company, a 5,000 person company, or a 2,000 person company that has automated and outsourced more aggressively? You divested your China operations. With the benefit of hindsight, was that a defensive move you wish you had made earlier, or a forced move you wish you would have delayed?
Felt like this was a headwind that we really didn't want to fight. You're never going to build a commercially effective, production-worthy probe card that has probes spaced at 2 microns. It's just not going to work.
Hello and welcome back to the Semiconductor Leadership Podcast. I'm your host, Salah Nasri, and yes, whether you are a semiconductor veteran or someone who's just curious about semiconductor manufacturing, this is your podcast. So, as they say, it takes a village to raise a chip, and it also takes a village to raise a podcast. So hit that subscribe button. Without further ado, many of you have asked me since the last couple of episodes that I did to conduct an interview with someone that you all wanted to hear from. Ladies and gentlemen, I have Mike Slessor, CEO of FormFactor, right in front of me today. So for those who are not aware, Mike Slessor has served as Chief Executive Officer at FormFactor since 2014. And as a director since 2013, Mike served as president from 2013 to 2014 and as SVP and GM of MicroProbe product group from 2012 to 2013. So he's really got the FormFactor blood inside him. And before joining FormFactor, he was president and chief executive officer of MicroProbe in the early 2000s. And of course, the acquisition happened with FormFactor and MicroProbe. And yes, he became the CEO of FormFactor. He received his PhD in Aeronautics and Physics from the California Institute of Tech, aka Caltech, and his BA in Science and Engineering Physics from the University of British Columbia. So he's got the Canadian genes in him. Mike, welcome to the show.
Thanks for having me.
It's such a pleasure, such an honor to have you. I do want to talk about the education part, because I think I know I did a little mistake in the last FormFactor update for the world to know. But we'll talk about that after the rapid fire round. So
Sure.
for the guests out there, the engineers, the investors, the Minister of States that are watching this podcast, we'd like to do a rapid fire round with you just to get them to know who you are.
Fire away.
Fire away, bang. Mike, probe cards or advanced packaging? Where is the more interesting engineering happening right now?
Well, I'm going to talk my own book, Probe Cards. We got all kinds of fun challenges.
Nice. Caltech Aeronautics or KLA Semiconductor, which taught you more about solving hard problems?
Caltech, hands down.
Nice. One book every semiconductor CEO should read that has nothing to do with semiconductors.
Barbarians at the Gate. It's the story of the RJR Nabisco leveraged buyout.
Nice. I've not read that. I'm going to have to get that on the list.
Great book.
The most underestimated part of semiconductor test in 3 words.
The speed and complexity.
Okay. One more word. Speed, complexity,
and difficulty.
Difficulty. There you go. The app on your phone you couldn't live without.
I discussed this one with my wife. Life 360.
What's Life 360?
It's a tracking app.
All right. It's an so you don't get lost. Coffee or something stronger when a customer escalation lands at 6 a.m.?
Coffee. You got to have your head screwed on straight.
Yeah, that's good. In one word, how would your team describe your leadership style?
Evolving.
Biggest myth about what test and measurement actually contributes to semiconductor yield?
That it's non-value add.
Oh, that's a genuine one.
Provocative.
Very much provocative indeed. If you weren't in semiconductors, Mike, what would you be doing?
I'd be a fly fishing guide.
A fly fishing guide. Wow. Did not know that.
Yeah.
That's something. I'm a big fisher.
Are you?
I love fishing. To be continued. It's actually the place where it's my meditation.
Same for me, right? Growing up in BC, taught as a small kid. That's what I do for sparing.
It's amazing. And the adrenaline when you catch one. Yeah. What's one thing you've learned about running a public company that surprised you most?
You have to be very careful with time management. Investor relations consume all of every day.
Wow. So going back, I want to dig in a little mistake that I did, and I accidentally said that Mike graduated from Stanford. So can you share to the audience what the real story is?
Yeah.
So tell us. We're all intrigued to hear about this.
No, I had a brief flirtation with Stanford.
Yeah.
But did go to graduate school, got my master's and PhD from Caltech down the road. And at least academically, there's a bit of a rivalry between Caltech and Stanford. So, but I forgive you. I ended up at Caltech. When I came out of UBC, I thought I wanted to be an academic. I thought I wanted to be a professor.
Yes.
And got into a variety of grad schools, 2 of them being Caltech and Stanford, because those are, at least back then, feeding grounds for academic. And my parents, to their eternal credit, made me go visit, right? Went to Stanford first, and as a kid from small town British Columbia, was utterly intimidated by the place, right? Huge university, people everywhere. People were very nice, but I felt like I'd get lost in the shuffle. Second leg of the trip went down to Pasadena and Caltech, much smaller school, 1,000 undergraduates, 1,000 graduate students, felt like a family place. Now it's a very competitive place, but felt like a place where at least you wouldn't get lost in the machine. So I ended up going to Caltech, had some struggles early on, right? As most people, coming from a second tier school. Well, I shouldn't say that about UBC, but coming from where I did, great baseline, but were some, you had to hustle to keep up there.
Well, thank you for sharing that. Well, it's great to have you. I mean, you've had quite a journey, Mike. You start from a PhD in aeronautics and physics at Caltech to applications engineering and product marketing at KLA to building MicroProbe as a CEO and then leading to the acquisition into FormFactor, where you now have served as CEO since 2014.
Correct.
Can you give us a short version of how you got here?
Yeah. I think the theme that goes through it all, there's a lot of right place, right time, and luck through the whole thing. As I said, I thought I wanted to be an academic. But after seeing what the inside of that was like, didn't want to do it. But it was the late 90s, and it was really easy to find a job with a Caltech PhD. Job I ended up taking was with Allied Signal in Sunnyvale as a thin film process engineer. But very quickly, we ended up having a defectivity problem. So I got introduced to the team at KLA, and in rapid order, they offered me a job as an applications engineer, and ended up at KLA at a time where, some of the real names of wafer fab equipment were the management team. Ken Schroeder was the CEO. Ken Levy was still around. Gary Dickerson was the COO. Rick Wallace, who's the current CEO, was the GM of my division. So some wonderful people to learn from, and managed to get myself hooked up with a growing product line, learned a lot there, and then, spent a few years working my way through applications engineer, product marketing, and on. But for a variety of personal reasons, we wanted to get the family back to Southern California. And so I took a job again in Caltech in the tech transfer office. Wanted to learn something about startups, IP, that kind of thing. But one day, a former customer from Intel Capital came in, and they were going to invest in a company called MicroProbe, but they needed a CEO that they trusted. So right place, right time. I'd been back at Caltech about 18 months, got to coach the kids soccer. My golf handicap was going down, but I was getting itchy. And so this came along. I jumped. And together with some of the MicroProbe founding team, we grew that business to about $100 million. And then from 2008 to 2012, in 2012, sold it to FormFactor, and a whole bunch of us stayed on and helped with the integration. One thing led to another, and one of my dreams had become to become a public company CEO, and the board offered me that position in 2014.
Wow. Remarkable.
Yeah, it is.
Congratulations.
So very much characterized by, being in the right place at the right time, which is basically luck, but also maybe having the courage is too strong a word, but the aggressiveness to go jump at some of these opportunities when they emerge in front of you.
Yeah. I mean, KLA is one of the most technically demanding commercial environments in the semiconductor industry.
Yeah.
What did working there teach you about the relationship between deep technology knowledge and commercial success? So, learning amongst the likes of Gary Dickerson, Rick Wallace, Ken Levi, these big names. What was the key takeaway for you?
Yeah, that deep technical knowledge isn't any good unless it's a commercial success, right? And that was in that environment. And it's a lesson that has stood me in good stead throughout my entire career, right? Our job in, private enterprise is to create value for our customers, share in that value, reinvest it in R&D, and keep that cycle moving. And that was really, really one of the key lessons of how to be successful in the semiconductor industry that was taught. And it was a big change, right? I'd come from almost a purely academic environment where a cool idea was a fun thing to be celebrated. At KLA, you were taught that a cool idea without real ROI goes in the trash.
Business is business, as they say. What's interesting about yourself is that you have a PhD in aeronautics and physics, not semiconductor engineering.
Right.
How does that background, thinking about fluid dynamics and physical systems, actually show up in your approach or the approach that you had in the semiconductor business?
Yeah, and I think many people, will tell you this is it has a degree like that has very little to do with the domain knowledge. It's teaching you how to think, how to learn, how to attack complex system level problems.
Right.
And that's I'm very fortunate to be in a group at Caltech that approached aeronautics, physics, applied physics, the combination of material science, electrical engineering. You were expected to be very broad and pretty deep, and then be able to synthesize complex technical problems and come up with a coherent solution. So it was less about the domain of the PhD and more about the breadth and the expectation to be able to learn about anything and solve any problem.
And that's pretty much the trend of our industry. You're unlearning, learning, unlearning on it.
That's right.
You've been the CEO of FormFactor for over a decade, which is an unusually long tenure in the semiconductor industry. What has kept the role interesting for you? And we'd be intrigued to know is how has your approach to the job evolved since 2014 to today's world that we live in?
Yeah. It's that same theme, right? Of learning, of evolving, of, hey, I don't quite understand that, but let me go learn more. And it spans not just technology, which is obviously constantly changing in this industry, but business models. You look at what AI is doing to the overall value chain in the semiconductor industry. There's lots to learn and analyze and think about there. And even leadership style. You asked me earlier what the one word about leadership was. It's evolving. I've had to learn, MicroProbe when I came in was 100 people, right? That's a very different leadership environment than FormFactor today at 2,200 people. And all of the steps in between, that's probably been the biggest learning experience throughout my career is how to lead people at a different scale in a technology company where everything's changing so quickly.
Right. What's interesting about FormFactor is it sits at a critical intersection of test, measurement, and advanced semiconductor development. I'd be intrigued to know, when you're talking to customers like TSMC or Intel, how do you frame FormFactor's value? I mean, could you share what's the core story and what does the actual customer really care about?
Yeah. When I think about our brand, right, and what FormFactor does well and what customers look to us for, it's solving really hard technical problems. We've always been good at that, right? Going back to the company's founding with some people that came out of IBM Watson Labs in 1995. The piece that we've finally put together with it at scale is being able to deliver those technical solutions in a high quality, repeatable way. And that's a natural phase for a company to go through. But conversation with customers always about the technology we can deliver. How can we solve this problem? And now has been augmented by some great operational capability and the ability to deliver those technical solutions at scale.
Right. Based on the analysis that I've done with regards to FormFactor is the forte that you have in patents. Is that your biggest frustration? The IP matters around there, because that's what really makes you unique. But then there's a lot of copycats around in the world. Does that cause you a bit of headache in the work that you do?
But that's true in any hardware technology company that has a technology leadership position. FormFactor actually was much more aggressive in terms of intellectual property and patents and lawsuits a little bit before and around the time I got here. Right. Interestingly, one of my first IP lawsuit experiences was FormFactor sued MicroProbe in 2010.
Oh, really? Oh, God. Wow. Wow.
And although I learned something back at the Caltech Tech Transfer Office about IP, I hadn't learned how to be deposed and how to really arm wrestle a lawsuit. In the end, it turned out well because it forced Tom St. Dennis, who was the CEO of FormFactor at the time, now our chairman, and I to sit down and get to know each other, and ultimately resulted in this merger, the acquisition of MicroProbe by FormFactor, as we began to see the value of bringing our teams together.
So this is interlinking to what you were saying about right time and luck.
Yeah. It's a defining arc through my entire career.
That's remarkable. I want to talk about the quantum side of things, because this is really interesting for us as well. This is something that we're delving in. And just before you had a podcast with Nobel Prize winner, Dr. John Martinez. Yeah. And his thesis is that quantum computing's next decade runs through the semiconductor fab. Fab-grade materials, fab-grade defect control, fab-grade yield discipline. FormFactor's building the cryogenic test infrastructure his industry is running on. Yep. So from your seat, I'm going to ask a cheeky question here. Is he right? And what does the rest of the semiconductor industry still not understand about what he is asking to do?
I'll answer the second part first.
Okay.
Right? Obviously, given our investments, I at least partially agree with them. So the more interesting question is, why hasn't the semiconductor industry sort of migrated en masse to go? It's a question of risk and scale and timing, right?
Right.
everybody in the semiconductor supply chain has a limited R&D budget, a limited customer engagement. And right now, with the industry running as hot it is because of high performance compute and AI, there's some real choices to be made. I think so. Is it a compelling place to invest? We think so. That's why we've made a couple of acquisitions, and we strongly believe that we can carve out a leadership position in enabling the testing for quantum computers. Now, that's unique because it happens very close to absolute zero, right?
Right.
All of these different modalities, as they're called, ways to build qubits, need to run close to absolute zero. So there's some really interesting core expertise that we have in probing and testing close to absolute zero that we're leveraging here. So do I believe him? Yes. It's going to take a while. These technology changes always take longer than the evangelists would believe, but it's also a fantastic opportunity to lead a brand new part of the compute industry forward. Quantum computers aren't going to replace von Neumann computers, but they are going to augment them at some point here.
Yeah. So let's talk about where the money actually is.
Okay.
HBM4. Double stack bandwidth to over 2 terabits per second. Could you walk our audience through the math in terms of how does test intensity actually grow per HBM4 stack versus HBM3 in test time? Also, if you could share about in probe card complexity and what will make economic sense in dollar context as well.
Right. So I think it makes most sense to talk about the transition from HBM3 or 3E to 4. So what happens in that transition? Two things happen. One, the stacks of DRAM die get higher. HBM3, largely 8 high. HBM4, 12 and even 16 high. And if your customers are going to assemble all these die together, they need very high confidence that each of those die is good. Right. Otherwise, you can imagine as a 16 high stack, if one of the 16 die is bad, all 16 are bad.
Right.
There's very little opportunity for rework, redundancy, things like that. So simply put, as we go from HBM3 to HBM4, there's twice as many die in the stack. That means twice as much test. Right. Now, there's some offsets to that with yield and that sort of thing. But to first order, that's the math that's at work. The other element that we generally refer to as complexity is the speeds are going up, right? And as we go from HBM3 to HBM4, the speeds essentially double, right? Getting close to, something like 10, 12 gigabit per second, which is a very complex test problem. We've invested over the years. If you think about our acquisition history, we acquired Cascade Microtech back in 2016. We felt like there was going to be a need for high-speed test knowledge. Cascade was the leader in RF, and we've propagated all of that learning and know-how through things like our HBM business over the years. So let's tie that to economics. Customers need more probe cards per HBM4 die out because the stack's higher, and it's a more capable probe card. Needs to run at higher speed. Simply put, that's a higher value piece of equipment, and we get paid more for it.
I love it. It's a great business to be in.
Yeah.
You said you are gaining share at all three HBM manufacturers. Without naming names, what specifically did the share loser lose on? Would you say it was speed, parallelism, cost, or the technical fit?
Yeah, no, it's the combination of high speed and parallelism, right? And for those of you who are not familiar with the concept of parallelism, it's pretty simple. It's a fancy word for how many die you can test at once.
Yes.
And you can imagine that directly correlates to throughput and therefore cost for our customers. So one of the capabilities we have that is differentiated is the ability to test many die, hundreds of die at once at these high speeds. And so those are the places with HBM4, HBM4E, and on to HBM5, where we're gaining share at each of the major DRAM manufacturers. Now, it's a part of the overall DRAM market, right? Something like high speeds really have no value in commodity DRAM tests, but in the HBM place of the market, that's where we're differentiated. That's where we're gaining share.
Yeah. And now I want to switch into the supply chain and geopolitics, which is vital to understand. I think this might be an interesting one for you. You can always say NDA or no comment, Salah. You divested your China operations. With the benefit of hindsight, was that a defensive move you wish you had made earlier, or a forced move you wish you would have delayed?
I think our timing was pretty good. Now, it was largely in response to a couple of different factors. The primary one being I think it was the fall of 2022, the U.S. Department of Commerce came out with some relatively restrictive export controls for shipping advanced node equipment and consumables to China. And it turns out that because a probe card is specific to each customer chip design, it's pretty easy to map whether a probe card is going to go to an advanced node design or not. There's not this general, well, it could be used for trailing edge. No, it's used for a specific design. So we looked at that. We also looked at where we were gaining momentum in things like HBM and high-end foundry and logic in co-packaged optics, and felt like this was a headwind that we really didn't want to fight. China had been, I think, up to probably 25% of revenue, but nowhere near the 50% that some of the wafer fab equipment companies had. So we made the decision, and this was, I guess, late 23 into 24, to divest the business. We still do business in China, but through distribution. What we wanted to make sure was that, again, we were making the appropriate choices to prioritize where the company's really focused. And I think high-performance compute and advanced packaging, even back then, were pretty obvious places to focus.
Right. Makes sense. Texas Farmers Branch is a Brownfield acquisition, not a Greenfield build. Mike, why Brownfield? And could you share, like, what does that say about how the industry should actually scale U.S. capacity in this decade versus the romantic version of CHIPS Act fab construction?
So just so everybody's on the same page, Greenfield is where you buy a chunk of land and put up a fab and facilitize it, and that's a multi-year process.
Right.
Brownfield is where you buy an existing site and start a little further down that path, and that's precisely the rationale for faster time to capacity. We bought it about a year ago, maybe a little less than a year ago. We've publicly disclosed our plans to bring it online later this year in the fourth quarter. There's no way if we bought a chunk of land that we'd be anywhere close to bringing it online this quarter, in the fourth quarter. And so our motivations were largely to do with time. Now, it turned out that the economics were pretty good as well, right? We got it for a fair price. It was nearly a perfect fit for us, where maybe it wasn't a perfect fit for some of the other potential buyers, and have received some pretty generous incentives from the city of Farmers Branch and the state of Texas.
Very nice. All right, I'll sway away from the geopolitical questions because
Texas is not really.
No, it's not. It's the first one. It was a great move. Let's go into the technical and strategic depth, which is something that is very profound about yourself. You're very technical for a CEO. So, co-packaged optics is suddenly real after a decade of being almost real. Sounds similar to quantum, maybe. Or could be. From a wafer test standpoint, what is the engineering problem CPO actually creates that the industry has not yet publicly admitted that is really hard or hard?
From a wafer test perspective, the things that are hard is all of a sudden you're not just interacting with the chip through physical contacts with electrons flowing through things. You're also interacting with the chip with photons, through non-physical connections. You bring up lenses and fibers close to the device. You transact photons in and out of the device. That's a completely different set of engineering and implementation than test floors run on today. I think those problems are getting pretty close to being solved, at least at a fundamental level. We're going to have to dramatically increase the productivity of this for it to be commercially viable, but we're in such early stages of CPO. So right now, several different options for where the module gets tested, whether it's just the photonic IC or PIC, whether it's the PIC and the EIC together after they're packaged, all of that stuff sorting itself out. But I think the fundamental problems of introducing photons to the equation have been largely solved, and we're beginning to ramp in production. The productivity is going to be the next big engineering challenge, and that's where we think FormFactor has a big advantage, right? We own a lot of the photonic IP and enabling subcomponents for the photonic piece of it. We're also obviously a world leader in electrical probe cards, and these two things are going to have to come together in something like an electro-optical probe card, something we're working on right now with our key customers.
Fantastic. What about glass substrates? Intel's kind of pushing them. The OSATs are watching. Is glass a 5-year story or a 15-year story? And what does FormFactor's roadmap look like?
Well, again, that's a little bit either upstream or downstream, depending on how the flow works from where FormFactor sits. But I think an interesting question on the transition or at least the adoption of glass compared to polymer or organic substrates to where they are now. It's going to be driven by some sort of performance requirement. And the fascinating thing about the industry right now is the relentless and very, very high speed annual cadence. By speed here, I mean time on the calendar, right, of innovation. Technology solutions are being gobbled up by the high performance compute industry in the quest for higher performance, higher bandwidths, more storage, right? It's just a theme. My 25 years in the industry, I've never seen this pace of technical innovation and adoption, right? So the question is, where does glass become commercially viable in solving a key problem that has ROI for our customers? Because fundamentally, that's really all it's about. Can they sell their products for more? Can they differentiate by adopting them? It's still a few years out, right? But going back to CPO, I do think, and this is a loose connection, right? The fact that photons are becoming a much bigger part of the semiconductor industry, where electrons have been the transacting particle of choice, I think is going to motivate at least some applications to adopt a glass substrate with waveguides and different things. Much easier to implement in glass than in plastic, clearly.
Probe card lifetime economics at 2 nanometer and below.
Yeah.
With that type of element, when we're looking at technical perspectives, when the contact pitch shrinks below a certain point, the consumable economics starts to look very different. So where does that curve break from your perspective, and what is FormFactor's response?
Yeah. Well, there's two angles to that question, or two components to that question. One is probe card lifetime and what's required. And I got to go back to the fundamentals of what drives probe card demand, and that's when customers release a new design. Probe cards are not fungible across different chip designs, right? And one of the interesting things that's happened, when I first got in this business in 2008, lifetime was a very big deal because customers' product life cycles were very long. Fast forward, 20-ish years later, product life cycles, except in places like automotive and industrial, are much, much shorter. And so while lifetime is still important, when you think about the annual cadence in mobile, when you think about the annual cadence now in high-performance compute, it's pretty rare for a probe card to actually wear out, right?
Yeah.
It gets obsoleted instead by design changes. So that's one piece. Lifetime is not as big a part of the equation as it was years ago when customer product life cycles were longer. Back to then the pitch piece, right? So pitch, the spacing between the contacts that the probe card needs to touch and interface to. Probe cards have always sort of hijacked the packaging contacts. So flip chip bumps, wire bond pads, now hybrid copper pads, things like that. We've seen a decoupling of probe cards using the packaging pitches, and instead, many customers for the very fine pitch applications, instead putting in dummy test pads. Or, we've developed an innovative technology called the hybrid probe, where one probe touches multiple bumps, right? And so there's different ways to solve the problem without completely scaling the probe card pitch down to, hybrid bonding. We're talking about a few microns. You're never going to build a commercially effective, production-worthy probe card that has probes spaced at 2 microns. It's just not going to work. At least that's our estimation. Maybe somebody will come in and disrupt the industry. But so instead, different ways to solve the problem that essentially, move to a different paradigm of using the packaging contacts as the test interfaces.
Right. Let's go into the chiplet test perspective. Yeah. So if we look at the known good die yield and the move to test after singulation, Mike, from your perspective, in 3 to 5 years, does most advanced test happen at wafer level, at die level, or would you say at module level? And from that point of view, I'd be intrigued to know is that what shifts in your business at each scenario?
So I'm sorry, but I'm going to give you the it depends.
The it depends answer.
Right. Because think about all of those test insertions are available to our customers today, right? What they decide to spend on depends on the yield fallout at each of those steps. So for example, let's start at the wafer level, right? Wafer comes out of the fab, it gets probed. If it's got very high yield, often it doesn't make sense to continue to probe it, right?
Right.
Because there's not very much fallout. And fundamentally, the job of probe is to eliminate bad die that aren't going to work in the downstream processes, right? So if wafer yields or yields coming out of the wafer fab are very high, right? Probe, not very useful. Flip that around. If yields are low and die costs and packaging costs are high, then probe has huge ROI, right? So, and that's the situation we're in now with high performance compute. It's not the situation we're in with analog, for example, right? Where you've got very high yields and pretty low downstream packaging costs. So that's why it's an it depends answer. As you move further downstream, same logic applies. It's what is the yield fallout and incremental cost of yield fallout downstream, right? I think as the industry continues to build more and more complex devices with more and more chiplets in them, as long as we're continuing to advance nodes in complexity, number of transistors per die, I think wafer test is going to continue to be an awfully compelling thing to do at the leading edge of the semiconductor industry.
You have 2,200 employees today, as you mentioned.
Yeah.
If FormFactor is a $1.5 billion revenue in 5 years, are you a 3,000 person company, a 5,000 person company, or a 2,000 person company that has automated and outsourced more aggressively? What's in your mindset?
I think it's somewhere between the 3,000 and the 5,000. It can't be 5,000. If we're, let's keep things simple and look at math doubling, right? So if we say 2,200 people, we're going to double the size of the company. If we got 5,000 people, we haven't done our job as managers, right? We haven't gotten more effective. We're not scaling, right? We've let costs run out of control. 3,000 is probably a hair on the light side, right? We do run factories. One of the interesting things about probe cards, this is true largely of our systems business, but it doesn't have to be true. But I think it does have to be true for probe cards. We need to run our own MEMS factories to build these advanced MEMS probes that are the core of probe card capability and our differentiation. And that requires people, right?
Right.
It's not economically feasible to build a probe card fab with fully lights out 300 millimeter tools. These things for us and our competitors kind of look like 1980s vintage 200 millimeter fabs. So there's going to be some scaling of people. But if you look at our recent financial results, one of the things we've been able to do is add automation, yield improvement, different things to basically hold headcount flat as we've gone from 200 million a quarter to, we just guided the second quarter of 26 to 240 million. So there are underlying efficiency gains. That's true in our factories. It's true in especially our general and administrative processes, things like more effective handling of data. We're embracing bots for different tasks, a lot of self-service. So as managers, as leaders of the company, yeah, we need to invest in technology. We need to expand. We also need to be more efficient at the same time on a per unit output basis.
I see. Now I want to shift the discussion to more of a personal and strategic discussion. Thanks for sharing us the overview of your potential. I'm rooting for you. So 1.5 billion, here it comes. You've led FormFactor since 2014, over a decade.
Yeah.
What does FormFactor do today that the 2014 version of you would not have predicted?
Ooh, I would not have predicted CPO. Right?
You would have not predicted CPO, yeah. No. I don't think many. Well, we were speaking about CPO at our summits 2 years ago. So I'm knocking my head against the wall. So
yeah. So 2 years ago is different than 10. Yeah, right. And there were some people at FormFactor at that time who had the vision and the foresight to begin really thinking about optics. They come from our systems business, right? And here's where customers come into play. We started to engage with customers on this. And there was a set of like-minded people in some of the labs at our customers who we began to collaborate with. But the tipping point does feel like it was 2, 3, 4 years ago, probably 3 years ago, where it became clear that major customers were going to insert CPO on their roadmap. I could have never predicted that in 2014.
Yeah. If only we knew.
Yeah. Well, it's always been such a compelling solution for energy efficient data transmission at high speeds, right? But that need, the commercial need, never really emerged until we got into this AI era where huge data centers consuming a ton of energy and power are transacting an immense amount of information. Okay, all of a sudden now there's a need there. That needs a solution. Bingo. Optics and CPO.
Yeah. Evident as our audience can see, your PhD is kicking in this discussion.
Well,
you're not just a CEO. Can you share, Mike, which technical decision in the last 5 years that you made personally over your engineering team's recommendation, and how did it turn out?
And this is part of my evolution as a leader.
Yeah,
I don't think I've made one of those decisions.
That's it. Okay.
Now I've pushed them. I've asked a bunch of questions. We've had, some architectures where we struggled with development and it started to smell just technically too complex. Right. And so, you challenge an engineering team to go back to the drawing board and simplify. And that's where I do think, a strong technical background helps, right? It also helps externally because our customers are very technical people too. Even senior managers at these customers, many of them have PhDs, certainly all of them have bachelor's degrees in engineering. And so, when you think about running a technology hardware business and making R&D decisions as we go through as an executive team and plan where we're going to place our bets, it's a useful part of the intuition that's built up over the years.
Yes. What is the question, Mike? And I know you want to say this, and I think I'm giving you the opportunity to say this right now. But what is the question your investors keep asking that you think misses the point? And what is the question that they should be asking instead?
Well, it depends you again. Depends on their time horizon, right? Right now, and I don't know when this is going to air, but we're right on the heels of doing our Q1 earnings call 24 hours ago, right? Yeah. Lots of questions about capacity constraints, near-term potential. What are you going to do next quarter? What are you going to do in the fourth quarter, right? And for many investors, that's a relevant time frame, right? Yeah. For those who have a longer term view, I think it's probably more useful to ask questions about how we're going to continue to grow, both on the technology differentiation side. We talked a little bit about HBM and where we have a competitive advantage. There's examples of that all throughout the FormFactor roadmap.
Yes.
And how we're going to deliver, right, all of this technology as the industry grows. And of course, we plan to gain market share on the back of that technology and competitive advantage. There's some questions around that, but often very focused on the here and now. So I think, let's put it this way. I'm very enthusiastic about our long-term future, right? It's not to say I'm not enthusiastic about our short-term future, but when I look at where the industry's going with this intersection of advanced packaging and high-performance compute and how test and probe become so important, right, in enabling that, really the long-term, and by long, I mean several years, not decades, right? I think is a really interesting place to understand where FormFactor's going.
So let's say 5 years from now, is the bigger FormFactor revenue line from the probe cards or the systems?
It probably continues to be probe cards. Probe cards right now, about 80% of our business.
Okay.
And if you look at systems, has a very important place in development. For CPO, we're now transitioning what's been learned in development to pilot production. But as I said, over time, that also probably transitions into an electro-optical probe card. And if you look at this why is test important for advanced packaging and high-performance compute, it's really associated with probe to make sure bad die don't go downstream. So I expect that business to, the overall market to grow. And as I said, based on the R&D investments and customer relationships we have, we expect to grow market share as well.
In terms of career wisdom, Mike, what's been the most difficult decision you've made in your career? And I'm not saying CEO, in your career.
In careers. I've got two for you in two different contexts. One where personal intersected career. I told you, right, that ended up leaving KLA to get the family back to Southern California and was fortunate to have a landing spot at Caltech in the tech transfer office. That was a tough decision, right? You knew KLA, great company. I'd learned a ton. There was certainly upward potential there, but, you know, we're living up in the Bay Area. My wife's family's all from Southern California. We had the only grandkids of the family. They were 3-year-old twins, right? And I was never home, right? You know, Taiwan, Korea, China, Singapore. That was a tough decision. And ultimately, as many of us do, had to come down on the side of family. Now, obviously, I get super lucky, right, with the MicroProbe opportunity and get to re-enter and use everything I'd learned at KLA to help grow MicroProbe and then transition into FormFactor and be allowed to run this place. Purely professionally, the toughest decision I ever had to make was the acquisition of Cascade Microtech in 2016.
Why?
I'd been CEO for a year and a bit. Cascade, you know, there'd been interactions over the years, right? Even back to MicroProbe days. It was such a natural fit, but this was a bet the company move from FormFactor with me still wet behind the ears as a public company CEO. I agonized over this decision, and it didn't help that we weren't as operationally strong as we were today. And in the quarter the deal was announced, we missed the quarter badly. So I had a bit of a problem on my hands, right? Fortunately, you know, we pressed on, did the deal, good for both sets of teams and products and companies. But at the time, that was a very, very difficult decision to go, yes, we're going ahead.
What was the biggest lesson from that?
I think it again goes to, I tend to be a relatively conservative, not politically, but, you know, judgment-wise. Sometimes you just got to push your chips in. When all of the data lines up, you're always going to have some reservations in a complex decision. But when it's time to push the chips in the middle, push the chips in the middle.
What's your most proudest moment of your career?
I think it's really this latest transition at FormFactor where we've broken through, we were kind of a $500 million, $600 million annual revenue company, struggled operationally, as I said, great technology, but delivering that on time in compelling products and then ramping those in volume, something we were never good at. I think, the last several, call them 4 quarters, have shown that we can now do that. And that required me several years ago to sit down and completely reassess the company I'd helped build, right? It was essentially a turnaround at scale, right? Now, when I came into FormFactor in 2012, Tom and I worked together to turn the company around from a near-death experience. Was unprofitable, burning cash, losing market share. It's easy to get people motivated because their very existence or their company's very existence is at stake.
Yeah.
It's a whole lot harder when things are kind of going okay, but you're not achieving the full potential. I'm proudest of what we as a leadership team have done in sort of breaking through this next phase. And really, I think demonstrating over multiple quarters here that we're on a track to really drive to strong market share gains and significant growth, both on the top line and on the EPS line.
What's a misconception people outside the industry might have about what test and measurement actually does?
Yeah. I think it goes back.
Why does it matter? That's the most important thing, right?
It goes back to a little bit of the string of why test is important for advanced packaging and what you asked me in our opening rapid fire session. Test is not just quality control, right? It's not end of the line test and measurement. It's not end of the line, oh, this part doesn't work, throw it in the trash bin. Right? It's an integral part of the overall semiconductor process. If you look at measurement and metrology, clearly those are in-fab feedback loops. They're helping change the process real time to improve yield. Say you look at wafer probe and wafer test for advanced packaging, same kind of impact. If you look at what our customers are doing, they're selecting different die to go with other die to get the highest performance system, right? Now, in the simplest cases, they're discarding die, but that also makes for a better yielding, higher performance system. So it's not just QC, it's really an integral part of a high yielding, high performance semiconductor process.
Mike, if you could point to one transformative shift coming in semiconductor test and measurement over the next decade, something that most people aren't fully paying attention to yet, what would it be?
Well, I think we've touched on it, and a lot more people are paying attention to it because of CPO.
Okay.
But it's the introduction of photons to the semiconductor industry, right? This idea, and it touches the glass substrate question, the quantum question, right? The industry's always worked on electrons.
Yeah.
Right. And we're now seeing, and I firmly believe this is the first step where photons, where light becomes a key partner to electricity in how compute works and how data gets transacted. And I think CPO is kind of just the first chapter of this.
Yeah. Mike, if you look at your career, and let's say if I asked you, could you share someone in specific who's had a massive impact in your career?
Yeah.
Who would that be?
There's a few that come to mind immediately, right? Mentors, bosses. I talked about, Tom and I starting to see eye to eye, and he was I guess he still is my manager at the chairman of the board. Well, that's different. He's been a real influence. Somebody like my PhD advisor, Paul Nematakis, early in my life, then went on to become the chief technologist at Jet Propulsion, National Jet Propulsion Lab for a stint. Very influential, somebody you work with in your early 20s. I think one of the people, though, that I really want to highlight is Bobby Bell at KLA. Bobby was assigned to be my mentor when I was an up-and-coming product marketing guy. And I've said this in several public forums. I gave a talk at the IEEE conference a few years ago, and I gave Bobby credit for this at the beginning. He taught me how to really communicate to executives and different people, right, who don't communicate like scientists and engineers. And the thing that stuck with me, he helped me with, my executive review presentations, my PLC phase exit review presentations. And the thing I took from it, and I'm sure he said this in this many words, was tell them what you're going to tell them, right? When you're trained as an engineer and a scientist, you go through hypothesis, supporting data. Everybody's asleep or angry and frustrated if you try and do that in a fast-paced commercial environment. He taught me to flip it around, give them your conclusion, and then build in the supporting facts. And that's been super valuable for me, not just internally as an executive, but one of the things you got to be able to do as a public company executive is take the complex, right, and deliver a clean, clear, crisp message to investors. Super smart people, but generalists, right? Many of them don't have technology background. So you got to be able to explain it in a clear, coherent way. And, that lesson or set of lessons from Bobby have been a very important part of my success as an executive.
Remarkable. Last one, and of course it's a big one. Wrapping up this marvelous discussion with you, Mike, is what's the end goal? What's the legacy? Why are you doing this for?
Yeah.
What's the purpose?
Well, I think for probably a lot of CEOs, it's the same purpose when you've been somewhere for a while. And I feel like, I went into MicroProbe in 2008, came to FormFactor in 2012, but that was pretty continuous. It wasn't really changing jobs. It was helping integrate two companies. And so when I look at my career, 90% of it has been spent at FormFactor, right? And that gives you a mentality of, I won't say a founder, because that's a different thing. Igor and Ben and the people that founded this place had a huge entrepreneurial spirit. But I do feel significant ownership and responsibility for the state of FormFactor and the sustainability of FormFactor when I leave, if I drop dead, that sort of thing. And so when you think about legacy, and again, I think this is true for many long-tenured CEOs, right? It's about, did we together build something that endures and persists and thrives beyond all of us?
Beyond the absence.
Yeah.
That's deep. That's very deep. So, Mike, I mean, from your perspective and seeing what you've seen today, is there anything that you would look back at the beginning or look back in your career that you would change?
Yeah.
What would it be?
I've been very fortunate, and we talked about right place, right time.
Yeah.
Those are very non-linear trajectories.
Yeah.
So if I said I wanted to tweak with that, I don't know that it ends up.
Butterfly effects.
Those are very real, right?
Yeah.
Because if you look at the sequence, the overall arc makes sense, but any of the individual steps result in a new opportunity opening up, right? Or something that if you changed anything, I don't know that it ended up the same way. And I'm very lucky to be leading this company, to be working with the people I am. And so I think my simplest answer is I wouldn't change anything.
Yeah. I think one of the key things that one can take into consideration is you chose your priorities right. As in, you prioritized your family first.
Mm.
And that became a blessing in disguise that you didn't expect.
Right. Almost unintended.
But you chose what was vital, what was valuable. Yeah. And it turned out to your favor.
Yeah.
And that's something that to be very, very proud of. Thank you. Very, very proud of. Mike, do you have any last comments that you would like to share to the audience about FormFactor, or about what advice that you can give them? Or...
Well, I guess we have an intern class, I won't say every summer, but periodically here. And one of the questions they always ask me is, what, very eager, young, right? Well, how did you get where you are, right? And I think, one of the things I've learned is, you grow up, being trained as an engineer. My dad was a chemistry professor. My mom was a teacher. You sort of have this notion that things are linear, right? Things are, I do this, then that happens, then this, then this, then this. And, now in my, mid to late 50s, I've recognized that things are highly nonlinear, especially when you get into a complex environment. And sometimes you just got to get lucky, right? Yeah. You put yourself in the right position, you put your company in the right position, but sometimes the chips just have to fall your way, right? And so the advice would be, when they do great, recognize what you did right, what you controlled, what you influenced to get in that position, but don't get too discouraged when the chips fall the other way. There is a large element of, I won't say luck, but randomness and fortune and different things that go into companies being successful and people being successful.
Thank you, Mike. I appreciate the fact that you used the analogy of chips, because that's what my book was written about. It's called The Game of Chips. It's a poker game.
I was thinking about poker chips, but...
Well, that's what my book's about. It's about poker.
Ah.
So the book I wrote, The Game of Chips, is using the analogy of semiconductors along with the analogy of poker, and how it's just a game of poker. It's who folds, who raises, who's got the royal flushes. So advanced packaging, co-package optics is now royal flush mode now. So I explain it in that type of analogy, so I respect that.
Well, there's another, that has something to do with semiconductors, but there's another book to put on the list.
True. Yeah. There you go, guys. Place that order. Mike, thank you so much for joining us on the Semiconductor Leadership Podcast. It's been a marvelous discussion, and we wish you all the best and all the growth that needs to be. We're here to support you no matter what. And I look forward to the next discussion. Next time, maybe it'll be a discussion on when quantum proliferates.
Yes.
And we can talk about the technologies around that. But it was an absolute pleasure.
Great. For me as well. Thank you, Salah.
Thank you, Mike. Ladies and gentlemen, thank you for tuning in to the Semiconductor Leadership Podcast. If you want to get more details on FormFactor, you can look right above me here. Formfactor.com will pop up. You can check out their websites, check out their career website, check out the products that they have as well if you're a customer watching this, and investor relations as well on there for you guys that are watching as well in that community. In the meantime, if you enjoyed the episode, hit that like button, comment, share, and as I say, it takes a village to raise a chip and takes a village to raise a podcast. So hit that subscribe button, and I'll be very, very grateful for your support. But in the meantime, I wish you all the best, and take care, and I look forward to seeing you at the next episode. Bye for now.